Sean.
Hey everyone, welcome to Grab Time with Sara and Sean. I'm Sara.
And I'm Sean. Sara and I make art using math.
We sure we sure do make art using math, and I'm so excited for today's episode. Sean and I have been playing around with math all day, and we can't wait to do it with you two. We've been using sine and cosine functions to make some cool stuff. Sean, I think we should just start and show us the original inspiration from many years ago.
Yeah. And honestly, Sara and I were just like playing with things, and we were like, we got to record because we were just having so much fun. So basically, what we did was we took a look at this graph that I made some years ago, and this is one of my favorite graphs. And one of the reasons it's my favorite graph is because I made it entirely by accident. So what I love about this graph is it has a bunch of sines and cosines and trigonometry in it. And it just sort of like rotates through different phases of it and different scale factors and things like that. And what happens is patterns just like sort of magically emerge out of it. Sometimes it looks totally random, like just noise. And the crazy part about this is that there are so many patterns. If you just scroll through like every possible combination, it feels like there's a limitless number of patterns. Like it'll look like flowers, or it'll look like circles, or it'll look like completely crazy things. And none of this was planned. I was just trying to make sort of a firework thing, and I accidentally hit play on one of the sliders, and these magical patterns underlying in math revealed themselves, and it was super exciting. So we played around with that. We kind of figured out how it works. We recreated it in a much simpler version, and we're excited to share it with you today. So I'm going to just clear all this out of here and start a brand new graph. So the first thing we need here is a circle. Now, on one of our previous episodes, we did a circle kind of like this, except I'm a rebel, so I start with sine, even though that's not the way you're supposed to do it. It still works. This is a special way of making a graph in Desmos called a parametric. We're not going to get too much into it. We'll just like accept that this makes a circle.
The more standard version is cosine's the x value.
How it works is basically cosine is all of the x values. And so I put that sort of in the x position here. Sine is all of the y values on a circle. So I put that in the y. And once you have, like, even if you don't totally understand how it works, it's fine. Like, you can just start playing around with this. All right, I'm actually just going to switch these around because
you're Sean and you like to put sine first.
Because I'm such a rebel. It's not that I just like make the same mistake over and over again. The way that I think about this is that as you put more and more into this first expression, like if I make this a 4 pi, or if I make it an 8 pi, or I make it a 10 pi, the way that I think about it is it's sort of just twisting up the function, because now they're going really fast, but the y's are still doing a circle. So the x's go back and forth a lot, and it just helps in my brain to think of it like a twisting action, right?
And right now, the x and the y are not being twisted like the same amount. So that's why we're seeing it like kind of have all these overlaps.
Yeah, exactly. And if I did make it twist the same amount, it would be just a circle again. It's not really just a circle. What's actually happening is it's 5 circles, but because they're perfectly in sync with each other, we just see one circle in the end.
Mm-hmm.
You know, you could go crazy with this and say like, oh, I want to twist this up a lot of times, and then okay, we broke it too many times. But like eventually the calculator can't like handle it anymore, but it's just like more and more twists, and you can get like really fun things happening when you twist these in different ways. But we're going to do something a little bit special with this. We're going to take this and we're going to add a second circle, and so that just makes a bigger circle. But what we want to do with this is actually kind of twist this second circle up more while this first circle is going around. Okay,
so we're going to have the first, like our original circle is going to be rotating, and then we're going to have some like twists happening as it rotates.
Yeah, exactly. Because we were kind of wanting to do like a spirograph sort of thing with this. So we're gonna go around a circle while twisting. Okay.
Love it.
So watch what it's. So I'm gonna call this like twists.
Oh, that's a good name.
And I'm gonna put this in here. And I'm going to leave the pi there because that helps things sync up a little bit better. But watch what I have. So we'll say like, okay, we can go to 1 twist, like 100 twists. And then I'm
I'm
just going
actually
to,
so curious.
yeah, I'm just going to make this. So this is, what's going to happen is
Oh, I
it's
see
going
a
to,
twist.
yeah, it's going to twist as it goes around the circle. So instead of just twisting left and right, we're twisting like a whole new circle, both
Uh-huh.
the sine and the cosine. And we can see it happening because instead of just being in one position, we're moving around a circle while we're doing it. So I can now twist and twist and twist and twist and
Oh
twist.
my goodness. Okay.
And the
Wow.
higher we go, the more twists we get. We go crazy with it, put 1,000 twists on it, and then it's like we can't even see what's happening anymore. All right, I'll chill on the twists. So that's the first part of what we're doing in order
Oh
to
my
see
gosh.
some like magical patterns of math.
Wait,
Okay.
Sean,
Yeah.
I have a cool request. So T is going from 0 to 1. I just want to see if you put like a slider, like if T is going to 0 to A, can we see how this thing's getting drawn?
Oh, here? That's
Yeah.
a really cool idea. Okay, so we're gonna go, we want that to go from 0 to 1.
Yeah.
And I'm just gonna type in 0 so we don't give
Yeah,
any away.
yeah. A quick
So
review.
yeah, so maybe I'll just hit play here. There we go. Yeah, so we can like draw this function out. Very fun.
Okay, cool. Thank you. Ah, that's so fun.
Okay, so now we gotta, so in order to see these like crazy patterns revealing, what we have to do is take a sample from this crazy pattern here. And so what we're gonna do is we're gonna make a list. So I'm gonna call it L sample. So we're gonna take points along this curve. And when we take points along that curve, crazy patterns will reveal themselves that we would never expect. And I only kind of like discovered by accident. So
And one important thing about sampling, so like kind of how A goes from 0 to 1, you're going to pick points between 0 and 1.
yeah, let me get that out of there for now. We can go back if we want, but I also want this to go from 0 to 1 so that it kind of will end where my function ends. So let's start with just like 100 points. I'm going to divide it by 100. So now this is, we always like to make things go from 0 to 1 because things that go from 0 to 1 are like predictable and we don't have to think about nearly as much when we do. So, okay, so here's my sample and I'm going to make a copy of this and hide the original function. And I'm just going to go to all these t's and I'm going to put this in. So this is going to just take 100, technically 101 points along this curve. And actually, I'm going to hide it because it'll be a bigger reveal. And also my computer won't completely freeze up when I type this in because I'm pretty sure it would otherwise. All right, turn it back on, see what happens. Whoa, that is
Okay.
not what I thought was going to happen.
No, not at all what I was expecting.
Maybe let's make these points a little smaller because we're going to make a lot of them.
And maybe
Okay.
turn off the grid at this point.
Okay. Yeah, let's turn it off. Okay, so let's like look at the original function. Let me make these a different color. Let's look at the original function. Okay, so when we took 100 points along here, it was moving so fast that we sort of got out of sync with it, right? So if I turn the number of twists down, we could.
Oh, maybe you could make the black dots like I can't see them as much as I wish I could.
Yeah, maybe. No, that's way worse.
Maybe make
Maybe
them
change this.
squares. Yeah, that's
Ooh,
good.
squares would be good too. Or diamonds, fun.
Okay, cool. That's good. I can see them a lot.
If we didn't have a lot of twists, we would see exactly what we'd expect, which is just kind
Mm-hmm.
of like points along the curve. But as we add more twists in, what happens is we don't have enough points to hit everything, and we get sort of a pattern. The crazy part about this is as you change this, the number of twists, and you sample 100 times, all of these different patterns emerge, which is what we saw in that like original graph that we were looking at. So we can, yeah. So, but I kind of want to see more points. It's feeling like a little too sparse for me. So let's like actually make the number of points controllable too, because what happens is as you sample different number of points, you'll get crazy different patterns as well. We can add like more and more points, and we'll also see different patterns.
Oh my gosh.
Oh my
Already
gosh, look at that one.
immediately. Okay. Okay, Sean.
All right, cool. So actually, I think I'm just gonna stop it there, and we're gonna pass it over to Sarah, and she's just gonna play with this a little bit.
All
But yeah,
right, let's do it. This is so much fun. So I'm thinking about a few things. I feel like we can add some stylistic vibes into here. The black background, perhaps,
I love the black backgrounds. We can make
especially for this
everything look.
cool art stuff. Okay, well, everything disappeared.
Yeah, maybe not with black points, but
I like the orange. Do you like the orange?
I want to go. We'll play with it. I want to try some different things, but we can do it later.
Okay. I'm just gonna kind of press play on the twists real quick and see what happens.
Yeah, so basically when you're seeing these like random looking parts, what's happening, I think, as far as I understand, is that the like your sample is just very out of sync with the period of the function. So it doesn't line up into anything special. As they get more in sync, like if you get like one is twice as much as the other, or you're doing like 100 twists and you have 100 points, like things start lining up and you start seeing the patterns.
Another thing I think would be really cool is what if we drew some lines between the points?
Yeah, that could be wild.
I'm gonna give it a try.
How
And
about like
connect
an off-white? I feel like could be.
an off-white. Let's see. Oh, and these lines I'm gonna want to be really thin. Maybe
Yeah,
one.
nice.
Well, you know what? I think that, well, there we go. Maybe I want to try between 100 and
Oh my
200
gosh.
and
Even
300.
just putting 100 in there.
I know. Okay, off. Oh, but it kind of looks like a sun. Oh
Yeah.
my goodness. Okay, yeah, let's do an off-white color. HSV. Oh, I need to give it a name. Off-white. Okay, this is white. Maybe this is off-white. Okay. Do you like this color?
Yeah, yeah. That's nice.
Oh
Yeah.
my goodness.
Honestly, I think just find like let's try to find as many. That's wild. Can you zoom in a little bit? That's awesome. I wonder what that looks like just as points. I mean, I like the lines, but
Yeah,
we
yeah,
can come
yeah.
back to it. But I'm like just curious specifically what this one looks like as points. It's just 4 circles? What?
I wasn't expecting that at all. Let's see. Orange is a good color to is this a good color to see both of them? I don't know. We can go back and forth.
Yeah, yeah. I like going back and forth. It's fun to see them.
Yeah,
That's wild.
that is so wild. Okay.
Oh my gosh. Immediately. Amazing.
They're so beautiful. Some things are really unexpected.
Yeah, and it's like it's so crazy because it's like we're not really like doing anything specific on purpose here. We're just sort of like we're like I don't know, like we're just
Oh,
exploring
these are
like the
cool.
patterns that can emerge when you do such a thing.
Yeah.
Well, I like some of the like ones that aren't totally symmetrical.
Yeah.
Maybe not
Like
this
this.
one.
Oh, you don't like that one?
Well, it's just a little too crazy at the top. Though that one's neat.
I like when they line up to be nice, like, oh, these are some of my favorite ones.
Whoa. Oh my gosh. Oh, that one's so cool. I love that one.
Yeah, it's just like remarkable.
Yeah. It's crazy like and I think like there's I mean, I get maybe there's a limit to this, but I, I mean, I feel like I've played with this for hours and there's just so many patterns that arise that you just would never even expect. And if you go to like a totally different like range of numbers, you'll see something completely new appear. Oh, that was just two concentric circles. But it
Yeah.
looks so cool with the lines. Like
Yeah.
some of them look really neat with the lines, and some of them look really neat as points. Well, that one's awesome. Oh, that one is kind of does look how you'd expect. I think.
Yeah.
I don't even know what to expect anymore. It feels like this beauty just like exists in math, and we're like discovering it. You know
Yeah.
what I mean?
It's really is something.
Oh, that one just has like a star in the middle.
Yeah.
That's a pretty fun one, and that one doesn't really look like the other ones either. You know?
No, I wonder. Wow, I thought maybe there would be a star for more versions of it.
Yeah, that one's like just exists for one tiny little moment.
Oh, I turned off the.
Whoa, that's really interesting. It like doesn't line up right in the point,
Oh, yeah.
but it looks like really nice with the lines. That's very interesting. Yeah, I wonder about like, okay, so one of the reasons that these patterns are emerging is because the frequency that you're wrapping around, like the frequency within the sine and cosines, is sort of different than the frequency you're sampling at. Another way to get them out of sync would be to mess with the sines and cosines and like make the sine and cosine different somehow.
Oh.
I'm not
Wow.
really sure like which way, like how to make them different, but I think in the second one. Whoa,
Uh,
what?
you
What?
missed it.
I totally missed it. I was just looking.
Okay,
That's
this is a
crazy.
2. There, and now I
Wait,
got rid of the 2.
that's crazy.
But it's not always interesting.
Yeah. That was like you just hit a gold mine there somehow. You just like were perfectly. Oh, that's fun too.
Yeah. Okay, I'm gonna put the 2 back.
Yeah, try some different ones with that. See if we can find something new.
Okay, so one weird thing though is that um when they're like too out of sync, or
Yeah.
when we put things in here, it's actually like I think I want to make it smaller. Whoa.
Yeah. And we like kind of will generate randomish numbers. Whoa, that's fun.
It looks spooky. This looks
Yeah,
scary.
that's like yeah.
Like a fountain or
Yeah,
something.
it is like a fountain.
A really
Well,
scary fountain. I don't know.
I don't find it scary. Be brave. Be brave, Sarah. Yeah. So when they're out of sync, they start looking really random and like really noise. And sometimes we'll use that intentionally in order to make things seem random by just getting them so out of sync that it's like impossible to predict what you would
Oh,
get.
but now I feel like the points might actually look less. Oh, the points are actually very um whoa.
Yeah. But what should happen is eventually these should end up sort of getting in sync with each other somehow, but it
Yeah,
might be hard to find exactly where.
yeah. So we really made that super random. It's gonna be like this is now ovally because I made the sign
Oh,
twice
it's like
as
oh,
much.
whoa, it's like getting 3D.
Yeah.
That's pretty cool.
Oh, some of these are like this almost is looking like telescopy.
It feels like it's like rotating into the backgrounds now a little bit,
Yeah,
like three-dimensionally.
I need to make it so slow if we're gonna see it.
Wait, Sarah, I have an idea. What if you kind of went back to the original version and made the sample number like really low?
Oh
What?
my gosh. Wow, this is like not at all. What if I
Yeah,
change?
try like a more like like 100 or something for the number of twists. Something like more predictable.
Oh my goodness. Okay, we have nothing. We have a line. We are
Chevron.
getting, well, okay.
Well, all right, that's pretty fun.
Let's see. What is the shape that we're on? Is it? Oh, I moved it. I hit it.
Oh, whoa, the squares is wild.
This one?
I like that one.
Yeah.
I don't think we saw this one yet.
Oh,
Yeah,
wow.
that's a good one.
That's
That's
like
a good one.
super spiky.
It's like a snowflake. All right. Well, thanks for joining us on this ride. We had a great time exploring like these underlying patterns of math, and we hope you did too. This graph is so fun to play with. I would highly recommend you go into the comments and check it out. And also, this entire journey that we've had was based on a mistake, like an accident. You know, be receptive to like making mistakes as a positive thing sometimes, and you might end up with something that's way better and more interesting than what you meant to do in the first place.
And if you find something really cool in a graph that you make, we would love for you to share it with us. You can leave it in the comments or you can email us at
Graph time, Sarah Sean
at
at
gmail.com.
gmail.com.
Thank you so much for joining today. Math has so much beauty to be discovered. Enjoy your days.